On this video, I'm going to talk about ideal gas law, alright? So ideal gas law is actually on the periodic table, which is PV equals nRT. P is pressure, V is volume, N is moles of gas, and T is temperature in Kelvin. Then what about R? R is actually stand for ideal gas constant R. My R, I can have two numbers. One is 0.0821, one is 8.31. So what is the difference between the two? If you look at this unit, you see that the 0.0821, the unit is L times ATM over mole K, okay? Which is, I can write on here, L times ATM over mole K. 8.31, right? You can also write that as 8.31. If it's a write as 8.31 will be L times KPA over mole K. So 8.31 L KPA over mole K. So this line here, you see the flashing line here, is this line. So whatever the thing before the flashing line will be on the top of the flashing line. Whatever after the line will be on the bottom of the flashing line. Okay, so when do I need to use which one? You compare the two units, you find out that the only difference is the pressure unit. So if your question gives you ATM, you use 0.0821. If the question gives you KPA, you use 8.31. So which is here. If the question gives you ATM, you use 0.0821. If the question gives you KPA, you use 8.31. And of course, temperature must be in Kelvin. And the volume I gave you usually is liter, so you don't have to do many of the math, right? So this was given to you in the periodic table. Now, how do I know that I need to do is an ideal gas law, which is I will not confuse with the combined gas law. Now, ideal gas law have two idea. One is a P, V, and T will be no change. Pressure, volume, and temperature will be no change. What does that mean? That means you can see that from the formula, I have no P1, P2, no V1, V2, no T1, T2. I only have one V, one P, and one temperature. No change. And number two, I will have involved number of moles. So N will be involved because in the question, I will have moles. In the formula, I will also have moles. So in this question, like the example here, okay, you list out the same thing. I have how many moles. I might change my temperature to be in Kelvin by adding 273, okay, and you write down, oh, my PVT no change, my N involved, so then I know it's ideal gas law, and then you write out the formula, you cancel whatever you don't want, and then you rewrite the formula and you put the numbers, and then make sure you cancel all the units successfully, which is like easy. But the only thing I want to point out is, how do you know that your R, right? I have two R here, 0.0821 and 8.31. So how do I know which one I'm using? Is again, you look up the unit of the pressure. The question, the unit is ATM. That means my unit here must be using ATM. So I have to use 0.0821. Okay, so whenever the question you have ATM, use 0.0821. If the question you have KPA, use 8.31. Okay, now let's look up this example. If I have 17 moles of gas at 67 degrees and 88.89 liter, what's the pressure of the gas in KPA? Right, so I'm going to use actually black pen. Okay, I'm using black pen to underline the KPA. Right, so let's first look it up. I have 17 moles, so it's N. But N what? N1, N2, or N? You look up the whole question, I don't have any other N. So this must be N only. 67 degrees is temperature. But T, T1 or T2, look it up, I don't have any other temperature. So this must be T. And same thing for 88.89 liter, this is volume. But V, V1 or V2, I don't have any other later. So this is V only. And what is the pressure in kilopascal? So I'm looking for P equals question mark KPA. Right? So now I'm listed out what I have. Okay, My N is 17 moles. My T is 67.0 degrees. And my V is 88.89 liter. And my P is question mark kPa. Okay, so we list out what we have. And then I'm going to go to the bottom. I'm going to write down my condition. All right, what do I have? I have my PVT. They all just one thing, no change. Right? Just on one P, one V, and one T. So I'm going to write down green pen. PVT, no change. Okay? And my N, involved. Right? So because of that, it is ideal gas law. Right? Now, if it's the ideal gas law, this is the ideal gas law. I'm going to write out the formula. Will be PV equals nRT. And then I'm going to rewrite this again. And I'm looking for my P, so I develop V on both sides. So I got P equals nRT. Right? Now I'm looking at A. I have my N, but I don't have my R. Right? So how do I know what's my R? Which R should I use? Should I use A 0.0821 or should I use 8.31? Again, you look up the pressure unit. So here my pressure unit is kPa. Because kPa, I can't use 0.0821. I have to use the one with the kPa, which is 8.31. So here I'm going to write on the list. My R, I'm using black pen. My R should be 8.31 L. So I'm following, copy this. L, kPa on the top, and then fraction line, and then mole K on the bottom. Okay, again, how do I know that I'm using this number? Okay, I'm going to draw the arrow. Okay, because I'm using kPa, so I'm using 8.31. Okay, you see that these two questions are not the same because this one is ATM, I'm using 0.0821. This question I'm using kPa, so I'm using 8.31. So don't mess up. Now after that, I'm going to start to plug in the numbers. So my N is 17.0 mole. And my R is 8.31 L kPa over mole K, right? And then my temperature, my temperature should be in Kelvin. I cannot put 67 degrees on here because if I put 67 degrees Celsius here, you see that degrees Celsius and Kelvin, I can't cancel the unit between Kelvin and degrees Celsius because they are not the same unit. So you realize that, oh, actually, I forgot to add the 273. So you see that if you did not check the unit cancellation, you probably just put the 67 there and you did not check the unit cancellation, you just do it randomly, you did not get the answer. So I need to add 273 here to get 340K. Right? Then now I can put my 340K here over my V, which is 88.89 liter. Right, now check the unit carefully. Mole on the top, mole on the bottom, cancel. Okay, K on the bottom, K on the bottom, cancel. L on the top, L on the bottom, cancel. And I do have kPa left over, which is exactly what I'm looking for. Okay, and then if you do the math, you get 540.35 09956, and you will get 540.35 kPa.